Hi, it's Anonymous, and today we're going to talk about vectors. So, a vector is simply a quantity that has a magnitude and a direction. For example, an example of a vector is wind speed. We say the wind is blowing northeast at 5 miles per hour. Well, if we draw a coordinate system, this would be north, south, east, and west. We can say, okay, the wind is blowing northeast, direction, at magnitude 5 miles per hour. 5 miles per hour. And this is an example of a vector. In general, velocity is a vector because velocity describes a speed and a direction. For this reason, you'll often see velocity written as v with a vector symbol on top. So if we just have speed, you may see that written as v with no vector symbol on top. But what really should be written is speed. So one interesting component of vectors is that they have components. You see, here we have a northern component and an eastern component. Given that it's blowing at exactly northeast, we can find the components very easily. Let me draw it again down here. Okay. So we have a northerly component going straight up, and an eastward component this way. And we know that it's going at 5 miles per hour in the northeast. But say I want to know the wind speed just in the north, or the wind speed just in the east. Well, given that we know it's exactly northeast, meaning it's exactly at a 45-degree angle, remembering that this is a 90-degree angle, this is a 90-degree angle, you can write 45 degrees, and given that this is 45 degrees, this must be 90, and given that the sides of the angles within a triangle must be equal to 180 degrees, then this must be 45 degrees as well. Therefore, we have something called an isosceles triangle, given that we have two sides that are equal and one side that is different. And with this type of triangle, we have x, x, and x rad 2. That's what we have in general for a 45, 45, 90 triangle. So then you could say x radical 2 is equal to 5 miles per hour. Therefore, x is equal to 5 over radical 2, dividing radical 2 on both sides. So what we really have is a wind direction in the north purely of 5 over radical 2 miles per hour, and in the east of 5 over radical 2 miles per hour as well, combining to make a combined vector of 5 miles per hour. An interesting thing to note here is that the resultant vector here in this case is bigger than its components, and we know that geometrically because the hypotenuse is of a 90-degree or triangle essentially is always bigger than the sides. So we know that the resultant, which is the 5 miles per hour, must be bigger than the components, which are 5 over radical 2 miles per hour and 5 over radical 2 miles per hour as well. If we take a look at the calculator, 5 divided by radical, there it is, radical 2 is equal to 3.53 miles per hour. And if you don't believe me and you want to check, just to make sure, we can use the Pythagorean theorem, which says a squared plus b squared equals c squared. Essentially the two sides, a and b, squared, a squared plus b squared, must be equal to the hypotenuse squared. So let's see, 5 over radical 2 squared plus 5 over radical 2 squared equals hypotenuse squared. So that would be 25 over 2 plus 25 over 2 equals hypotenuse squared. Okay, so now that is, given that we have a common denominator, we can just add the numerator, keep the denominator the same, equals c squared. That gives us 25 equals c squared. If we take the square root of both sides, that now gives us 5 equals c, which is what we would expect, given that the resultant velocity is 5 miles per hour. So that's an overview of vectors and how you can break them up into components and prove that you actually got the correct answer. It's been anonymous.